Hey Math 2, this is Miss Reynolds. Today we are going to learn how to do quadratic regressions in Desmos. I'm going to have the link to this Desmos graph saved to the description of this YouTube video so you guys can use it to save and submit your notes for today's lesson. So I've got examples 1 and 2 up in my notes on the left-hand side, and we've got Desmos on the right-hand side. So anytime that we're doing a regression for a quadratic model, we're going to be given a table or an equation or something to work with to put these values into, get the regression to predict other values that we are not given in the table. So here I have my table, and notice that it tells us to use x equals 1 for 1985. So we're not going to be dealing with these super huge numbers. So it's going to make our window a lot more friendly when we're looking at our graph. We need to make sure that we have already watched the video in Edpuzzle for how to set up regression in Desmos. It's very short, about 1 minute long, just to show you guys how to use Desmos and how to find the regression model. The most important thing about the regression model is this little squiggle called a tilde. This is what is going to predict the model instead of giving you an equation. So this A, B, and C value here are what we wrote over here for our equation. Then I had to find the value that y equaled when x was 26. And I knew that 2010 was going to equal 26 because if 1985 is 1, then that makes 1996 and then 11, so on and so forth. So then I add all the way up to 2010 to get 26. So when x is equal to 26, what I did right here was I typed this equation now that I got to predict the values I'm trying to find. I typed that equation in and I converted it to a table to give me this value, and it wants it to the nearest $1,000, so I just need $310,000 because that's what the table is entered as. And I am going to do example 3 from the beginning so you guys will be able to see how it's all entered in, but I wanted to go through these first 2 examples already worked out so we could see what was going on. So for number 2, so let's go ahead and close this first example. For example 2, we're looking at the sales of TV antennas. So this time I want us to pay more close attention to the data itself and what it means in context to the problem. So for number 1, we were just looking at the numbers, the table, how to enter it, and what all of that means. Now we're going to look at the actual data. So number 2 says the total sales S of TV antennas for various years from 1980 to 1995 are shown in the table below, where t equals 0 represents the year 1980. Sales are shown in millions of dollars. So there's a lot of really important information in this problem, just in the word problem part of it. So let's break it down a little bit. So the first thing we need to understand is that S is going to be my Y value. Sales is S. The difference between number 1 and number 2 is here my starting point t equals 0 is 1980 when before we used 1. And here my sales are in millions of dollars. So this is $77.3 million. Those units are important. So here we're going to determine our regression by entering the table. So I entered the table that I had here into Desmos. After we did that, I typed my regression formula and it gave me these A, B, and C values that I rounded here. It tells me to round to the nearest thousandth. That is very important that we are reading all of these directions for how we're supposed to round and what our units mean. Letter B, using the regression equation found, determine in what year sales reach their maximum. So I need to understand what this question is asking me before I can find the actual answer. To understand what's going on, I need to first know our vocabulary, that the maximum is talking about the vertex and the year is my x value. So it's going to be the x value of the vertex. So from here, let's turn off this top folder. Let's look at our regression here. So this red parabola is the prediction. The purple dots is the data that I was given. So if I'm trying to find what year will they be at their maximum, if I click on my parabola, this ordered pair tells me what my vertex is. So the x value of my vertex is 8.65. So if I add that to my starting year of 1980, and this is equal to 0, so I don't have to account for starting with 1, I get 1989. So that is the year it's going to reach its maximum. So after 1989, antenna sales started going down. And there's a lot of reasons we can contribute to these antenna sales going down, primarily because cable became more of a thing and people weren't using antennas as much. Last part, letter C. Use the regression equation to estimate the total sales of TV antennas for 2008. So the difference between A and B, well, for not A and B, between B and C is here, I was trying to find an X value. And for C, I'm trying to find a Y value. If I want to find the total sales, sales is the Y value. So I'm given an X value. Well, I'm given a year, 2008. I need to translate this to an X value. So I'm going to subtract 1980 to figure out how many years are between 1980 and 2008. And I get 28. So when t equals 28, that's what this x represents. X and t are the same. X is time. So when x equals 28, I'm looking at the intersection of my line at 28 years and my parabola, my prediction. So this kind of ties in with systems. When we're finding or predicting, whether it be sales or years, we are initially finding the intersection of that system. So here I have 12.6, so that's $12.6 million. So our next video, we're going to do example 3 from scratch, and I want you guys to try example 4.